we are doing today function families. Well, that's where your book titles it. I'm going to title this translations or transformations. So we'll call this function. You will need graph paper for some of the work tonight, but function, I don't know, transformations. Okay, there are six, I think six. And I want to stress this, and this is why I'm going to do it with function notation, is it does not matter what the function is. This works the same way all the time, no matter what it is. So we're going to start with our function f of x. And this can be anything. It can be a line, it can be absolute value. Actually, I'm going to go ahead and do it with absolute value because it will serve as a great example for what happens. So if I want to translate it, that means from geometry, move up or down, or left and right. I'm going to basically be adding values to this. So if I have f of x and I add some value k, this is going to move it up k units. Actually, if you could get your graphing calculator handy and set it to graph mode, we can easily see what's happening by getting to graph mode. So get to graph mode. I'm not going to put it up here because it'll just be so time consuming to always be plotting it, but on your calculator it'll go pretty fast. Alright, what do you think would happen if I did f of x minus k? What do you think would happen? It'd move what? And what it would move where? Down. Yeah, it would move down k units. Okay. Now the next ones are not as intuitive. If I do f of x plus h, that's going to move left h units.
So it's basically opposite?
Yep, it's opposite. Yep. And then if I do this, x minus h, that moves right h units. And I was wrong, there's actually 8 of these. So this is the first 4. These are the translations. These are where we move it up, down, left, right. Okay, the next one, if I do negative f of x, okay, that flips over the x-axis. And if I do f of negative x, that flips over the y-axis. And then we have 2 more after this, but we're going to practice these first 6. except I'll actually give you a function. So again, I want to emphasize it doesn't matter what the function is. But I want to highlight something about the ones that I'm putting a star in next to. This means I replace x with whatever is in here. The other ones I'm just adding or subtracting some value, really. And it's pretty simple. Alright, I will come back to this slide. I want to get us to an example. So get on your graphing calculator, and in y1, so our f of x is going to be x squared. Alright? This is going to be our parent. This is called the parent function. It's whatever we start with.
We have to put f of x.
Not in our calculator. This is what we start with. Alright, so this is what we start with. So in our calculator, in y1, we're going to just put in x squared. That's our first thing. And we'll want our standard view window. Now let's say I want to translate this up 3 units. So in y2, I'm just going to add 3 to that. So I have x squared plus 3. Go ahead and graph that and verify that that's exactly what happens. Oh, this shouldn't be y1, that should be y2, right? Okay, so once again, in y1, you put this. And we're going to translate that up 3 units. So in y2, you're going to put this, and based upon the notes we just took, we expected to move the graph up 3 units. Yeah, so you graph it, or draw it. You press draw. So your calculator should give you 2 plots on the same picture, and it should basically look like one of them's like this, and the other one is up 3 more. Something like that. Okay?
What if I just drew a line, like mine just drew a line across?
Your view window won't be messed up. So you're going to go view window, and you're going to verify that your x min is negative 10, your x max is 10, your y min is negative 10, and your y max is 10. Now, in the future, anytime you don't get what we're expecting, you need to first check your view window to make sure that that is or if you have the Casio, you can just switch it to standard view window. You should get something like this. Okay, that's because your second one is put in. So let's see. You forgot your x squared. Okay, so it did move it up 3 units, right? You with me? Yes, okay. So it did that. So what do you think would happen if we replaced y2 with x squared minus 3? What should happen? Yes, this should go down 3 units. Try it.
We're not graph these because they're like big on you.
It's 10.
I know. You don't feel like making a big old chart. It's going to
count
take up half the page.
by 2s.
I have to count by 2s. It's so hard. All right, so verify. Did it go down 3 units? Okay, so it went down 3 units. All right, what if I wanted to go right 3 units? Now this is where it gets tricky. This is what we put in. So notice in our notes, if I want to go right, I replace x with however much. So over here, I'm going to replace x in parentheses with x minus 3. Verify that that goes right 3 units. Yep, it It went right 3 units. And finally, if we want to go left 3 units, what would I put in Y2? Yeah, x plus 3 in parentheses squared. And that will go left 3 units. Verify that that's what happens. All right, we're going to use this as our next parent. Without the calculator, I want you to describe each transformation. I'll do the first couple with you. And this year, when we do graphs, we are actually going to use the facts that we are doing now to make graphing them way easy. If you could just buy into what we're doing. So, let's say g of x is okay, so this first one, what do you think the transformation is? Nope. Nope. Up to. Our transformations are, if we have f of x and I add something to the end of it, that's up, okay. If I have f of x and then I subtract something, see, this is my parent, that's what I start with. See, this is identical and I just add 2 to it. If I have f of x and then I put it inside, so that one's down. This one is left. And this one is right. So what does this one do? This one's left 2. How about this one? Yeah, down 2. It's when it's on the inside of the stuff that is a little bit more. How about this one? What? Right 2. These two we haven't reviewed yet, but if the negative's on the outside, that's going to be a flip over x. So like, what that means is if it's up here, well then it becomes down here. Yeah, it's a mirror. It's a reflection. Actually, we should call it, instead of a flip, we should call it a reflection. So it's a reflect in x. Yep, this one's going to be a reflect in y. So you replace t with a variable, and then you got x and y, and you plotted x and y. So your first point should be -6, down to 10. 2, 4, 6, 2, 4, 6.
What happens if you have 2 points on the same? I had 2 at the same point. Just point over them.
Yeah, it just happens twice. So when you graph this, when you connect them, now I don't know if it says to connect them or not, but you graph, like, this is your first point, is this your second?
Yeah.
And then is this your third?
That's my third.
That's your third? Ooh, that's weird.
And then
0, -1.
that's cool. That's minutes.
No, that's not 0, -1. 0, -1 is.
Oh yeah, I was counting backwards.
So that will go there.
And then it goes back to there and then it goes there.
I don't think they want you to connect them.
No.
Something might have went wrong though. Use your graphing calculator, switch it to parametric mode, and see it verified. Now your graphing calculator's going to connect it. So, instead of showing individual points.
Okay.
All right. Anyways,
You just not want us to connect it.
what does the book show at the back?
It just says. It just says graphic.
Okay.
Do you want us to connect it or not?
I guess not.
Okay.
If they give you those specific T's, did they give you those T's?
Yeah.
Then don't connect.
Okay.
Okay. Any questions on how we get these? Okay. Now we're going to mix them up. We're going to keep the root parent. This is the thing we begin with is our parent. So this is our parent. And all the rest of the things are the children. So let's get some children into the mix here. So these will be way harder. Because we have multiple transformations going on at once. So if we describe this first transformation, it would be right 3, up 4. Because the stuff inside with x, yes, and is left right. So the stuff inside with x is left and right, and the stuff outside is up and down. You with me? Okay. The next one, what should it be? Reflections are going to happen first. So this one reflects in what? Yep, it reflects over the y-axis. Huh? Well, let's go ahead and graph it, and then you can see what's happening. Because it's inside with x, is the reason why. So let's do our y1 as square root x, and let's do our y2 as square root of negative x. And what you should get, if you look up here before you graph it. In the first one, you should get this. The second one, you should get this. It should just flip it over the axis.
Can you go up?
Let me see exactly.
If you want to delete it, you do this.
All right. Did we verify that? Did it work out? All right. How about this other one? Oh wait, we didn't finish this one. It reflects over y, and then what? Up 4. How about this one?
It's going to be, it's like x. Left, left 5. And then down 3.
I'm not kidding. on your next quiz, you have a bunch of questions like this. Like these you're doing pretty good. You know, nail them. We also have to review our point slope form, so hopefully you are good on that. So this one is reflect what? And no? So remember the stuff inside with x is inverted of what you think it would be. Alright, so that deals with the first 6 transformations. We have 2 more. And we actually could just summarize it into just one. So I think we'll do that. We'll summarize it into just one, even though it's 2 different ones. If I have an f of x, and I multiply it out in front by some value, if that some value is greater than 1, then we have a horizontal compression by whatever amount a is, which is also going to be, well, yeah, we'll just do a horizontal. And if a is less than 1, like the absolute value is what I'm talking about, then it's a horizontal stretch. So basically, if I had something like this is what I started with, a function like this. And I had an a, I multiplied it by an a that's bigger than 1, then it's going to narrow it. It's going to smush it. And then if it's less than 1, that's the value, it's going to stretch it out. Now, if it equals 1, well, then nothing happens. All right? You don't need to draw those examples down there. But let's go ahead and put it all together. All right? And this is basically going to apply even when we get to trigonometry for the, like at the end of the year, this stuff comes up again and you'll be nailing the trigonometry if you buy into all these transformations now. It'll be way easier. So, if I have f of x, I have a times f of x minus h plus k. This is for any function. My transformation is a is a stretch compression factor. I don't know how to spell stretch. Stretch or compression factor. H is a translation, left-right. And K is a translation up, down. Yes?
So are you ready to do the common case picture for future?
In about 2 minutes I will be.
I had them. Do you want me to wait in here with?
I just need to finish up their notes. Okay, so that's basically what we did. If we remembered, if we did a negative x like that, that's a reflect in y. And if we did f of negative x, did I flip that around? My Vinova. I think, and this is a reflect in x. Huh?
X is the one on the outside.
Yes, it is. Thank you. I messed that up. This one's the up-down reflection. The one right here is the left-right reflection. But I forgot that the axis is there. Okay, so this is basically a summary of what we did today. And then to wrap it up so I can go talk to, get, beautified in a picture, have my beauty captured in evidence. Your book does throw you a curve. And they do something like this. And they ask for the transformation. Now, in absolute value, and if I have something squared, I'm not going to be able to do what I'm about to do. But I can never factor out from absolute value a negative. But I can factor out a whole number. So in that case, I could factor out the 3. So now this is a transformation. It is a horizontal compression of factor 3, because I have a 3 out there. It moves left 3 units and down 4 units. Now, so that you are not going crazy with all of these transformations that are in your homework, I want you to verify them with your graphing utility. Practice using your graphing calculator. So if it says to graph it, no need to do a hand-drawn graph, we'll say. Use your graphing utility and just verify it that way.
So we don't even need to copy what it's doing.
Right, you don't copy it down. You're on your honor for that. If you don't do it, you're not practicing the skills, so then don't ask me during a test or quiz how you do it on your calculator. You're on your honor that you figured that out. So that's it for your notes. I hope you found that